This question looks nice. Let's see. They're talking in three dimension R3, and then they have 2 points P and Q, and this denotes distance between X and Y points. So now they're defining a set X S. So it's collection of all X's such that this happens. Okay, and then accordingly they have defined what is a set T also, and they're asking which of the following statements are true. So definitely what we have to do is just get to know what is in my S. Okay, what kind of element are in S or what kind of element are in T, because all the questions are about S and T. Okay, so let's get going with the first one. It says that distance between X and P. Okay, so what do you think distance between X and P? X is something which is not known, which belongs to S. Okay, let's say X is looking like XYZ. Okay, this is how the coordinate is looking like. Now can you write this whole equation? Okay, x minus distance between X and P, between X and P. Okay, now subtract it with distance between X and Q. This whole thing is equal to what? 50 they have given. Okay, you have to form an equation out of this. Now let's try simplifying a little bit. You see this term is anyways cancelling. Okay, and you can simplify a little bit more. Okay, x square and z square definitely are going to get cancelled. Okay, so what are you left with is 6x plus 8z minus 55 is equal to 50. Okay, or you can write this same equation as 6x plus 8z is equal to 105. That's your equation. Okay, what is this? What equation did you get? Yeah, do you think it's equation of a plane? Basically all the points in the set S, okay, are lying on this plane. Okay, so all elements, all x belonging to S are here on this plane. Now, can you decode the T also? Do you think I need to do the similar kind of work? No, because you see that the same thing, okay, it's exactly the same thing, just that you can take a minus out. Okay, it's exactly the same thing. So if I take a minus out and I again say that y is equal to xyz is belonging to, let's say, T, okay, the same. So I will get the same thing, okay, just that I will get a minus outside. Minus times this is equal to 50. You get the point. Okay, because I'm assuming the same point is that if you take minus common outside, this will be plus and this will be minus. Okay, exactly the top equation. So I'm getting this. Now can you simplify this a little bit more? I will take this on the other side, and then I will get this to be 5. Okay, now this is another plane, you see. Okay, so all y belonging to T are going to lie on this plane. Can you also see what they are parallel planes? See, coefficients are same. The normal direction ratios are the same. Now let's start answering the questions. Okay, number A. There is a triangle whose area is 1 and all of whose vertex is from S. Okay, of course, right? It's a plane. Okay, what is S? Every point on this plane is S. So let's say this is my plane. 6x plus 8z is equal to 105. Of course, whatever triangle you want, you can form. Okay, if of area 1, yes. Area 2 is still S. Everything. Okay, so 1 is true. Okay, any triangle you can form on that plane. Number B. There are two distinct points L and M in T such that each point on the line segment LM is also in T. Of course, again. Okay, LM and R T. T is again a plane. Okay, a plane whose equation is given by 6x plus 8z. Doesn't matter, it's a plane. Okay, and if I take any 2 points on this plane, of course, I can have a line segment which is totally going to lie on the plane. Yes, okay, very simple. Let's answer the C part of the question. There are infinitely many rectangles of perimeter 48 whose two of whose vertices are from S. Okay, so they're asking, let's say this is my S, okay, and they're parallel. We saw that. Okay, this is my T. Now, is it possible to have a rectangle, two vertices here and two vertices here, such that what the perimeter is 48? That's what they're asking. So first of all, I need to know what's the distance between the two planes, right? Because this would be fixed because it's a rectangle. It has to be like perpendicular to both the planes, these two lines. Okay, so what's the distance between the two planes? This plane and this plane? Of course, you can write C1 minus C2 modulus. So this minus 5 modulus upon under root. Coefficients is square. Okay, 6 is square, 8 square under root. Okay, because there is no coefficient of y. Okay, how much do you get? This is 100. Okay, upon 10. Okay, that's 10. Okay, so this distance is 10. 10 and 10 is how much? 20. Okay, so this and this side sum up to 20. and you want the perimeter to be 48. So can you have something such that, okay, so how much is left? 48 minus 20. Okay, it's 28, right? Okay, so I can have, right, 14 and 14 here. I can have any 2 points such that they are 14 distance away, here and here. Okay, so of course there will be so many rectangles which I can have 14 distance away. Okay, so there's so many, this side, this side. Okay, there's so many rectangles you can have, any point, any 2 points which are 14 distance away you can have. Okay, so yes, there are infinitely many rectangles of perimeter 48. Now D is asking, can you have a square? Now that is stretching too much, right? Can you have a square? Square means that if here and here there are two planes, okay, you already said that this and this is sum up to 20, right? This is 10 and this is 10, they sum up to 20. So but you can't have 10 and 10 here, right? Okay, because you want 48. Okay, had they said that you want it to be 40, then fine. Okay, but D option is not true. Okay, interesting question.